The launch of NASA's Voyager probes marked the beginning of interstellar travel and demonstrated humanity's ability to explore not only Earth, but the far reaches of the solar system and beyond. Even after 45 years, these spacecraft continue to provide new information to scientists and provide new information about the world. Despite their limited memory capacity compared to modern smartphones and thousands of times slower than today's networks, these amazing machines are still at the forefront of space exploration. Voyager 1 and 2 were launched in 1977. Voyager 1 began its journey on September 5, just 15 days before, on August 20th, Voyager had already departed. Due to its parallel function, the two spacecraft, which were first tasked with surveying Jupiter, Saturn, and their moons, then embarked on an epic journey, reaching the far reaches of our celestial sphere. Voyager 1 and 2 have since broken records, going further than any other spacecraft and traveling farther from Earth than any human-made object in history, having entered interstellar space. These are the first human-made objects to travel beyond the influence of the Sun into this unknown universe. More than 12 billion miles from Earth, the spacecraft continues to surprise scientists with groundbreaking discoveries, including one surprising and shocking discovery. Voyager's observations made significant contributions to science during the mission. Their first discovery of the moons of Jupiter and Saturn contradicted previous assumptions and revealed that these distant worlds have a much more energetic environment than previously thought. Voyager 2 was the first spacecraft to fly by Uranus in 1986 and later visited Neptune in 1989. Expanding our knowledge of these distant planets, even decades later, NASA is still implementing strategies to extend the life of both spacecraft. By removing components and heaters, they plan to extend the Voyager program until around 2030. The spacecraft has exceeded expectations, and their withdrawal is a bittersweet moment for the scientists and engineers who have devoted their lives to the mission. The design of Voyager 1 and Voyager 2 is a testament to NASA's technological ingenuity. The two spacecraft are designed to maneuver smoothly and provide clear, crisp images as they move through space at incredible speeds. These imaging feats fascinated scientists and the public long before spacecraft reached the outer planets. Early images of Jupiter's swirling clouds and the Great Red Spot inspire viewers. The most famous is the discovery of volcanic activity on Jupiter's moon Io. Voyager found many volcanoes rising from the moon's surface, indicating that Io is the most volcanic in the solar system. Voyager 2 made several new discoveries of Uranus and Neptune. On Uranus, he discovered 10 unknown moons, while Neptune revealed the solar system's fast winds and cold, icy volcanoes on Triton, the largest moon. These discoveries of Neptune expanded our understanding of exoplanets and their moons. One of the most important moments in the mission came when famed astronomer Carl Sagan asked NASA to return Voyager 1's camera to Earth before the systems shut down. The result is the pale blue dot, an image of Earth from 3.8 billion miles away. This image became a profound symbol of our place in the universe, highlighting the fragility of our planet. Though both spacecraft still use outdated 8-track tape systems for data storage, they continue to transmit valuable information from the farthest corners of our cosmic neighborhood. NASA's use of gravity-assist maneuvers was another key to the success of the Voyager missions. These maneuvers allowed the spacecraft to conserve fuel while accelerating toward their destinations, using the gravitational pull of planets like Jupiter and Saturn to slingshot into deeper space. Communication with the Voyager spacecraft has been maintained through the Deep Space Network, DSN, a global system of radio antennas that enable NASA to send commands to and receive data from the probes. Even as they journey billions of miles from Earth as the Voyagers enter interstellar space, they encounter the heliopause, the region where the Sun's influence ceases. Voyager 1 provided the first direct evidence of this limit, and Voyager 2 later confirmed these findings. However, both spacecraft detected a sudden change in the direction of the magnetic field, which challenged existing theories. Looking ahead, the spacecraft will continue to travel to different constellations, Voyager 1 to Ophiuchus and Voyager 2 to Cetus. Although their mission is expected to end around 2030, the Voyagers could outlive humans and carry their golden records, Earth's messengers, into space for millions of years. Therefore, the Voyager mission is one of humanity's greatest achievements. Their legacy in space exploration will continue to inspire generations as they push the boundaries of what we know about the universe. revealing new mysteries and expand our understanding of the world. Another amazing discovery, the icy moon Europa, is one of Jupiter's 53 moons. Voyager reported that Europa's surface is covered by a thick icy crust, perhaps more than 60 miles deep. This discovery led to the intriguing idea that beneath this icy crust lies a vast ocean capable of sustaining life. These findings have increased interest in future missions to Europa, and scientists are eager to explore habitable areas. As the Voyager spacecraft left the Jovian system, Jupiter's pull forced it outward. This mechanism, called gravity assist, is key to allowing the Voyagers to conserve fuel and extend their missions beyond their original mission. Without this elevator, the spacecraft would not be able to escape the sun's pull, and their journeys would come to an abrupt end. Voyager 1's next major encounter was Saturn and its largest moon, Titan. Covered in a thick orange haze, Titan revealed a mysterious event. Voyager 1 found Titan's atmosphere to be mostly nitrogen and thick clouds of methane and ethane. Since the atmosphere was similar to that of the early Earth, this raised questions about the moon's ability to support life, even with prebiotic conditions. However, Titan's thick atmosphere prevented Voyager from seeing the surface, raising interest in future missions. Meanwhile, Voyager 2 will continue to fly past Uranus and Neptune, reaching the same levels as before. In 1986, it was the first spacecraft to fly past Uranus, giving humans the first close-up views of the planet and its moons. Voyager 2 discovered 10 unknown moons and discovered the magnetic field around the planet. Scientists were also surprised that Uranus has a strong rock that is rotating in both directions due to a previous collision with a large object. 3 years later, Voyager 2 approached Neptune and revealed new information about the distant planet. The spacecraft discovered Neptune's Great Dark Spot, a storm with wind speeds of up to 1,000 miles per hour, the fastest recorded in the solar system. In addition, Voyager 2 captured stunning images of Neptune's largest moon, Triton, showing nitrogen geysers erupting from its icy surface. Triton, one of the coldest objects in the solar system, has a retrograde spin, indicating that it was captured by Neptune's energy long ago after the planetary collisions. The two spaceships begin their interstellar journey. In 2012, Voyager 1 became the first human-made probe to enter this undiscovered region, crossing the heliopause, the region where the sun's influence ends and the interstellar medium begins. Voyager 2 followed up in 2018 and confirmed the data collected by its predecessor. The spacecraft's instruments detected a sudden increase in plasma density, a key indicator of interstellar travel. However, both spacecraft also recorded a sudden change in the direction of the magnetic field, challenging previous theories of the solar system's boundary. Now more than 12 billion miles from Earth, the Voyager spacecraft continue to send back data, though their operational capabilities have been gradually reduced to conserve power. In recent years, NASA has turned off non-essential systems and heaters to ensure the spacecraft can continue to function for as long as possible. Both Voyagers are expected to remain operational until around 2030, after which their power sources will be too depleted to support further communication with Earth. Despite their age, the Voyager spacecraft still use 8-track tape systems for data storage, a remarkable feat of engineering considering the harsh conditions of space. These tapes contain invaluable data that have provided scientists with unprecedented insights into the outer planets, moons, and interstellar space. One of the critical elements of the Voyager's success has been the Deep Space Network, DSN, a global system of radio antennas that allow NASA to communicate with spacecraft across vast distances. Without the DSN, the Voyager missions would have been impossible, as it enabled real-time adjustments and data reception from billions of miles away. As the Voyagers continue their pioneering journey into the cosmos, they carry with them the famous golden records. These phonograph records, attached to both spacecraft, contain sounds and images representing life on Earth, including greetings in 55 languages, music from different cultures, and natural sounds like birdsong and ocean waves. The golden records, curated by a team led by Carl Sagan, were designed as a message to any extraterrestrial civilization that might encounter the spacecraft in the distant future. Encased in protective aluminum covers and etched with instructions for playback, these records are intended to last for billions of years, potentially outliving humanity itself. In conclusion, The Voyager missions represent one of the greatest achievements in the history of space exploration. These spacecraft, launched more than 4 decades ago, have far surpassed their original objectives, traveling farther from Earth than any other man-made objects and providing groundbreaking scientific discoveries along the way. As they continue their interstellar odyssey, the Voyagers carry not only the data that have revolutionized our understanding of the cosmos but also a message from Earth. A testament to human curiosity, ingenuity, and the enduring desire to explore the unknown, the Voyager mission's legacy will continue to inspire future generations of scientists, engineers, and explorers, reminding us that the quest to understand the universe is a journey without end.